Hello, everyone, and good evening. I welcome you all to the second session of Science Talks organized by Science Association, Sir Parshuram Bhau College, Pune. Today, with us, the eminent speaker, Professor Saurabh Paul, Director, Indian Institute of Science Education and Research, ISER, Kolkata. He will deliver a talk on integrative science, a way forward. With us, we have Dr. Professor Vidya Avsare, Head Department of Chemistry. Also, my colleagues Dr. Srikant Musale and Ajinkya Thorat. So, I welcome you all. And now I would like to request Dr. Vidya Avsare to give the brief of Department of Chemistry. Please, ma'am.
Ma'am, your mic is mute.
Sorry. Thank you, Dr. Sandeep Kakade, for providing us opportunity to interact with our all science students through this platform, Science Talks. Uh, Department of Chemistry is one of the oldest department in SP College Pune, and we have been constantly doing lot of science related activities, student centric activities. Among that, in fact, a lot of students participate in science association program. There is one of the important competition we have been arranging, that is TR India lecture competition. Because of this COVID, we couldn't conduct it. And Department of Chemistry has largest number of faculty in college. So we have 18 permanent faculty. Most of them are PhD. Some of them are doing PhD. So lot of important projects are undergoing. Most of the faculty are publishing in very high impact factor journals. So Department of Chemistry, all of you know that it is one of the big, we have independent building also, and lot of good activities we are conducting under our department. And my colleagues are very enthusiastic. They involve students in their projects also. So students who are interested in carrying out a project, they are always welcome to chemistry department. And I hope all of you know that SP College is DBT Star College scheme. So we have a lot of events undergoing under this program. And I welcome Professor Pal, because in a short notice he accepted our invitation and he is there. And this is really one of the golden opportunities you students are getting to hear from the stalwarts. He is one of famous scientist. Of course, my colleague Dr. Shrikant Musle will talk about him. So I don't want to take more time, and I would like to hand over this stage to Dr. Shrikant Musle. Thank you.
Thank you, madam. Now, I would like to
Yeah.
request to introduce the today's eminent speaker, Professor Saurabh Paul, to our colleague, Dr. Srikant Musade. Please, sir.
Good evening, all of you. It's great honor for me to introduce and welcome our today's eminent speaker for this staringly beautiful evening. He's well-known and distinguished scientist of India. Today's eminent speaker, Honorable Professor Saurabh Pal, sir, is barely requires any introduction. Presently, he is director and professor at ISER Kolkata, that is Indian Institute of Science, Education and Research. Which academic background for which he pursued PhD from IAC Calcutta. IACS, it is Indian Association for Cultivation of Science. He completed post-graduation from IIT Kanpur with integrated course. He held different positions in his career. Presently, he is director and professor at ISER Kolkata. He was professor and institute chair professor at IIT Bombay from 2015 to 2017. He was director at CSR NCL Pune from 2010 to 2015. He was scientist at NCL, CSIR NCL Pune from 1982 to 2015. He is director at CSIR, Central Salt and Marine Chemical Research Institute, Bhavnagar, Gujarat, from 2014 to 2015. He was also the head and physical material chemistry at CSIR NCL Pune. For his outstanding and notable research, he was awarded with many awards and honors here. Sienna Rao Award in Chemistry and Material for CSIR from CSIR in 2014, Executive Council member from Federation of Asian Chemical Societies 2010. He awarded with J.C. Bose National Fellowship from DST in 2008. He was fellow of Indian National Science Academy from Indian National Science Academy 2003. For his notable research, he was also awarded with Shanti Sarup Bhatnagar Award from CSIR in 2000. A fellow of National Academy of Science from National Academy of Sciences in 1998. So I said the word that he has given awards for notable and outstanding research. He has published more than 265 research articles in reputed international journals. Many of these research papers are highly cited here. He has undertaken many projects, completed successfully several projects from DST, BRNS, CSIR. He has completed international projects, Indo-EU, FP7 project, Indo-Slovak, Indo-French, Indo-Mexico, presently having a collaborative with Indo-Mexico project. In addition, he conducted contract research with companies in India and abroad, namely Hindustan Lever, BASF, Germany, and USA. He guided more than 32 students for their PhD, and currently another 10 students are working towards completion for the PhDs. So with this introduction today, sir, we are privileged to have an opportunity to listen you at this evening. Welcome you, sir. Thank you.
Thank you. Thank you, Dr. Mushale. Thank you, Dr. Kakade, as well as Dr. Vidya Osare, Professor Vidya Osare, for inviting me to the stage of the Science Association in Pune. Of course, even if the invitation was in short notice, I always accept anything that comes from Pune. So that is one of the reasons I accepted, because I've been living in Pune, although right now I'm in Kolkata, that's my home. Pune is my hometown. So I've been living there probably longer than many of you have seen Pune. I think I've been seeing Pune since 1982 December. I think many of you may not have seen. I saw, Kothurut coming up in my eyes. There was nothing. There was no Baner. When I went, it was a very different city, Pune. And today I cannot imagine how it has grown from, a very small 600, 700,000 people to 6, 7 million people today. So I think it's amazing growth in 30 years. I've enjoyed in 33, 35 years that I have been in Pune. And then, of course, I was in Mumbai before I came here. So can you have this slide now? So let me thank the SP College Pune, and of course all my colleagues and friends of SP College Pune, Professor Vidya Osare, Professor Musale, Professor Kakade, and of course the Science Association by itself. And I have chosen in particular a topic of integrative science, the way forward. So can we bring the presentation from the backstage?
Yes.
Yes, sir.
Jay,
Please could you open the slides, then I'll add it to the screen.
you have to open it, sir.
I have to open it. Okay.
Yeah.
Yeah.
Is it coming?
Yes, sir. It's
Is it coming? Yeah.
Yeah.
All right. So is it okay now? Full screen?
Fine,
yes,
sir.
sir.
Okay, fine.
Go
So
ahead.
I have specifically titled it Integrative Science, the way forward. In fact, when Dr. Mushale was talking about me, he first mentioned that I did an integrated master's. So that integration of science was there with me for a very long time. In fact, I did integrated masters in chemistry at IIT Kanpur in 1972. I must say, this was the second batch of the integrated master's course anywhere in India. 1971, IIT Kanpur started. I entered in 1972. graduating in 1977. So I think the whole idea of integration was not there. It started in 70s with us. So we actually took a big plunge in not going for a conventional course. So I think it is very apt that I thought I would also talk about integrative science. And today, the national education policy, as many of you know, is talking about the integrative science, how to integrate research and innovation into the education. I think that is very important theme, and I will mention quite a bit of that. So as I said, I was in NCL. I was also at IIT Bombay. I'm sorry about this. IIT Bombay it should be. And I was a visiting professor of Ashoka. I am currently also a visiting professor of Ashoka University. So let me just say these three cities where I have lived. This is the currently Pune, Kolkata, Pune, Mumbai, where I have been living in most of my career. I think it's very interesting. Of course, each city has its own distinction, and it has certainly helped in building the research. I am currently at ICER Kolkata, so just a couple of slides on ICERs. In fact, ICERs integrate what I'm going to speak, the research in innovation, the theme of research in innovation in science. For all the students who are here, I must say that I'm sure you have already heard of ICER because there is one in Pune, with which actually I was associated from the beginning, being when I was in National Chemical Lab, and Kolkata came at the same time, Pune and Kolkata. And then, of course, there are a few others like in Chandigarh, Mohali, Tiruvandam, Bhopal, Tirupati, and Berhampur are the more recent ones in 2015 and 16. So there are 7 of them. And our major emphasis is to integrate research and innovation right from the undergraduate studies. So one of the major degrees, of course, that we give is BSMS, which is Bachelor of Science, Master of Science. It's an integrated course, 5-year course. And then we have, of course, integrated PhD, which means after BSc, somebody can come and directly get PhD. And then the standard PhD program. These are the 3 programs which are running. We are also planning to introduce specific, we already have a specific master's course, 2-year master's course. And probably at a later time, we will introduce a generally 2-year master's course. But right now, that is something that in general is absent. All the ICERs are doing very well, I must say that. And that has been seen, particularly Pune and Kolkata are doing very well in terms of admissions, in terms of NIRF ranking, and so on. So this is, of course, the ICER Kolkata campus. ICER Kolkata campus, which is spread in 201 acres of green land. Because we are a little bit away from Kolkata, so it has been easy to get such a big land. And we have, of course, the first phase of construction, which is ready. It's 117,000 square meter. And there is a natural lake which goes within our campus. So it's very nice scenario. It's very green, actually, as you can see already all around. We have been also very consistently ranked in the NIRF. And in fact, our latest ranking is overall 29, which is pretty good. Before I start, I must say that why do we study science? I think that is very important. And today it's a science association. So I must say that science, of course, provides your basic expertise, your knowledge of various subjects, physics, chemistry, mathematics, biology, etc. But the very important thing today in the theme is the multidisciplinary or interdisciplinary research. And each of these provide a platform. But each of these by itself does not contribute to the interdisciplinary research. So that really requires an amalgamation of all of these. We have lots of careers, and I'm going to go to the next slide to show that there are several opportunities because lots of students are here. After you pass out, you can go to the academic institutions like IITs, ICERs. Of course, to get to the academic institution, you have to typically get a faculty position. You have to get PhD, you have to do some postdoctoral studies anywhere in the world. And then you can hope to get jobs in IITs, ICERs, or National Institute of Technology, NITs, central universities, state universities, colleges. Of course, each of them have probably different eligibility criteria. It's not that everywhere you require postdocs and so on. But what I'm saying that these are the opportunities, academic opportunities which exist. Then there are research laboratories like NCL in Pune, which are under CSIR, IIC Bangalore, of course, Tata Institute of Fundamental Research, Mumbai, the Indian Association for the Cultivation of Science, where I did PhD. These are all research laboratories, and many of them are now turning into academic institutions. Like CSIR already has started a CSIR. IISc is also having undergraduate course. Many of you know it's a 4-year undergraduate course. TIFR along with Homi Bhabha National Institute is also doing undergraduate course. ISCS has also started about 2 years undergraduate course for 4-year undergraduate course. So many of them are having 4-year BS. We are having 5-year BSMS. So that there's a small variation. So, but these are primarily started as a research laboratories. Then you have what are called the mission-driven labs like atomic energy, space, defense, etc. You have opportunity to go to industry R&D. Very large opportunities, I must say, are opening up now. And a very important thing I must tell the students is the entrepreneurship. Very often we look for jobs, but remember, you can create jobs after you pass out. So there we can have a deep innovations through startups and so on. So entrepreneurship is coming up as a very big opportunity. And you must know that the government is funding the startup companies in a very big way now. There are lots of opportunities for research as well as international collaboration. I must say a few words on the national education policy because the new national education policy of this government actually wants to tell what we are, the theme of my talk, the integrative science, the way forward. In fact, it has come up with a major structural changes from the current educational system. So it is very important for the students to understand, especially in integrating research and innovation with education. I think that is very important. This policy exclusively lays stress on establishing stronger research institutes. So research is a very important theme. Promote R&D at the university level. And today, as you know, many universities don't have very good R&D infrastructure. So at the university level, state universities as well as national universities. So research and development is a very important theme of many universities. It's going to become an important theme. So this new policy focuses on the strategies needed to promote the research and innovation across all disciplines, promote how to do multidisciplinary research, and help India in becoming a global hub of R&D. I think that is the basic mission of the national education policy. The changes suggested provide a massive push to higher educational institutions. And I'm going to talk about higher educational institutions a little bit later. Which are higher educational institutions? Many of you may not know. These are the IITs, our ISRs, NITs, central universities, and so on. And these are basically controlled by the Ministry of Education, which used to be called Ministry of Human Resource Development, MHRD, and now renamed as Ministry of Education. I think those are basically the higher educational institution, and they lay a special emphasis on the strategies needed to promote research and innovation across all disciplines. I think this is very important to have education combined with the research and innovation. It's also important to realize that our overall expenditure, public expenditure on education in India has remained more or less 4.4, not even touched 4.5% of the entire gross domestic product, GDP. So one of the objectives of the NEP is to increase it to 6%. And I think that's a huge jump, as you can see. The expenditure on R&D, research and innovation has to be also increased from only 0.69% of GDP, the government expenditure, to become competitive with US, China, South Korea, which are 2 to 3% of the GDP. So of course, this is only for the research and innovation, and this is for the entire education. The entire education, of course, has much higher layout of expenditure. Coming to the higher educational institutions, one of the major focus will be how to integrate multidisciplinary education. So which means different disciplines, and different disciplines are required actually for innovation. So we have to give focus on research and innovation. And as I told you, it will be through the incubation centers, startup companies, technology development centers, which are called TDCs, centers in frontier research, greater industry academic linkage. I think that is very, very important in the new education policy to bring in innovation. And innovation has to come. Innovation is not very easy. And I'm going to talk about invention and innovation a little bit later. And it also talks about not only even in science education, interdisciplinary research, including humanities and social science. I think it is a very important part of the NEP. And I hope most of the science departments will also have humanities and social sciences as a curriculum to their course, because I think the NEP recognizes the importance of humanities and social sciences in the overall growth of human beings. So it's not just doing being a scientist or getting a degree in science, but I think it's an overall human growth that is very, very important. The government, the present government led by Modi ji has prioritized a diverse range of issues. So one of the things is to attract fund for research and innovation. I think this is very important because it's very easy to say that we'll promote, but there's a lot of funding that is required. And then, of course, there are a lot of interesting changes, administering the funds, networking with the global financing agencies, project drafting, implementation, monitoring, evaluation. Now, many of the students, of course, will not be involved. They will be the beneficiary of all this. But many faculties, as well as many other administrators, have to worry about it. How do you do networking with global agencies? And that is going to become very, very important. How do you draft good project? You have to consider outstanding research as a prerequisite for education and development. That is going to be the major changes. And it will suggest institutional and financing system of research and innovation in the country. And I think that financing is going to change. I think our mindset was always to get money from the government. Get money from Department of Science and Technology, DBT and all that. I think that kind of thing is going to change with the new education policy. One of the major changes that have happened, that the government has currently many arms of giving funding, like Department of Science and Technology, DBT. Professor Vidya Usare was talking of SP College being a DBT star college. So Department of Biotechnology, CSIR, and Atomic Energy, which are giving money for projects. So what this government wants to do is to bring in the new education policy one arm under National Research Foundation, just like NRF in US, and fund all diverse research in terms of projects. So I think that is very, very important so that the resource efficiency can be increased. Today, various agencies are giving money probably for the same project. So one can make an efficiency in handling the money in terms of project, in terms of material, in terms of human beings, and so on. I think that is one of the major objectives of integrating research. So the NRF will be established by an act of parliament. It will provide a greater credibility and legal authority to promote research within the country. I think that's very important. The institution will be given an annual grant of 20,000 crore, which is approximately 0.1% of the GDP, and will be expected to increase progressively over the years. So it's a very big, I should say, very ambitious project. The NRF would like to address the research-centric needs pertaining to funding across all disciplines. It will also look at research capacity. I think capacity building is very, very important. Just like in the colleges and many state, central universities, or even higher education institutions like IITs, our capacity is not global. Our capacity is not world-class. So we have to build infrastructure and create linkage. That is very important between various stakeholders like researchers, industry, government. They are the major stakeholders. So you have science, social sciences, technology, arts, and humanities. So very initial phase, these institutions will have 4 major divisions in NRF. It will have science, social sciences, technology, and arts and humanities. So it will catalyze quality research and promote research-friendly environment. And that is going to be the key goal. Of course, there will be a lot of recognition through prizes, awards, etc. In terms of universities, they will, as I said, they will have a considerable changes, and the focus will go to the multidisciplinary approach. It will provide greater leverage and academic freedom. So I just want to tell you what kind of institutions will come up. So this policy talks of 3 different types of research institutes. Type 1 will be the HEI, which will be basically world-class research and high-quality teaching across all disciplines. So that is the kind of thing that the IITs, ISERs, they attempt to do. So world-class research and quality teaching at the same time. Type 2 will be in the middle. They will focus on high-quality teaching across disciplines with significant contribution to research. Whereas type 3 will focus on mostly teaching at the undergraduate level. So, of course, you have to understand the type 2 will go beyond undergraduate to postgraduate as well as PhD, but type 3 will be simply undergraduate. Because I think the NEP also recognizes that asking everybody to do research is probably not worth doing, because that's a wastage of resources in terms of money, in terms of human powers. So I think that's a very important part. The other important changes that is coming up is how do you integrate the degrees? So for example, there will be keeping research in focus, it will offer different types of master's program. It will suggest continuing the 2-year master's program, but then the second year of this 2-year master's program will be entirely devoted to research. I think that is, again, I must say, many people are already doing it, many universities, but it says the entire second year will be research. So the first year will be the coursework. This will be offered to the students who already have attained BSc degree, bachelor's degree. Then there will be another kind of degree, which will be simply 1-year master's program, not 2-year. This will be offered again to students who will be completing a 4-year bachelor program with research. So this is exactly what is called BS degree. Many of you know in the United States and many countries, there's a 4-year BS degree. ISC has started it. So this 4-year BS degree, people who have already passed, they will actually do only 1-year program and get masters, because that will make it 5 years. Then, of course, there will be an integrated 5-year BSMS program, just like we are having ISER. And of course, there will be PhD, which will require either a master's degree, but very important change, that PhD can be done only with a 4-year BS degree. So somebody can do only a 4-year BS degree, may not do 1-year master's, but directly go to PhD. So that is going to be a possibility. So PhD degree will require either a master's degree of any kind, either integrated or 2-year master's or 1-year master's program after BS, but you can actually do only the BS degree. What it proposes to discontinue, I must say this, I have written in bold, is the MPhil. So many of you know that there is an MPhil degree which people take after the masters. So that is going to be discontinued. I think that's, those who have read the NEP would have seen that these degrees will remain, but the MPhil will be discontinued, because I think the people have probably realized that it is not really serving any big cause. And it has become, kind of people who are just have a intermittent time going for doing something. And today, with the education being linked to the research, just MPhil has no value. I must say that while we are talking of research, I am going to talk a little bit of chemistry education, because I am a chemist by profession. And in the chemistry also, it's very important that we integrate research in education. So this is a very, very important point. And today, of course, due to the COVID, chemistry has undergoing a lot of challenges, because along with biology, I think chemistry has a lot of responsibility to the society. Chemists have done a lot of interesting things, but we should not forget that any global fundamental science has come out of curiosity, has come out of necessity, has come out of accidental. There are several examples, like Archimedes, Isaac Newton. I think one should read, and the urea synthesis, and so many things which are accidental. So it's very difficult to predict how the research will come up. This is something that we must always remember. Whether we do multidisciplinary research or not, the original research is very hard to predict. One has to understand, however, the education is a major driver for the science and its applications. And that is where all the universities, IITs, ISERs, they have been established. And we are talking of now multidisciplinary education in the context of NEP. And so it's very important to break the conventional discipline-based education. And that is very difficult. I anticipate in a day, universities of the future will have a completely different kind of teaching. Is it necessary to have a class of physics, 8:30, 9:30 chemistry, 10:30 biology, where teachers come and teach in silos? Or I anticipate, in fact, I recently attended a panel discussion on chemistry of the future. That was Oxford academic leadership. Oxford actually organizes this annual panel. So it's a global panel discussion. So I was invited in this December. In fact, they were discussing on universities of the future. How would the future universities look like? And there I anticipate, and I made this point actually in the panel discussion, that you will not have a class of physics, chemistry, biology separately. What we'll have is a class on a theme, and that theme will require physics, chemistry, biology, everything, like virology. Now, understanding virus is a theme, but that will not be a biology course alone, because you'd have a physicist, data science people, chemistry, all of them will come and teach. So that is how the renewable energy, for example, would be a theme. That would be a class course. So I believe this multidisciplinary thing will come in a very big way. Probably in 15, 20 years, this might actually happen. Here I must show a very important slide, which is very famous slide, and many people have shown this, not the first time that I'm showing it. It has a quest for fundamental understanding on the y-axis, as you can see, and consideration of use on the x-axis. So this is basically application. So this quadrant, if you look at this quadrant, this is the low quadrant. So of course nobody would like to be here, but most of the students, when they enter education, they're here, which means their fundamental understanding is low. Of course, they have never worked on application. You can go to this higher understanding and low application. That is what is called Niels Bohr quadrant, which is called the pure basic research. Then you can go to the application only and less fundamental research. This is called the Edison quadrant. But what we have to go is a Pasteur quadrant, which is high science combined with high application. And this is very, very important. And this is called the use-inspired basic research. So the use-inspired basic research is something, I think that is where the students have to be moved here. The question is, how do you move here? Many of the universities in India come here. They're very good in basic research, but they can't move into application. It's not very easy to go there. You can come to the Edison quadrant, but then very rarely you can move up. What is required is, of course, the innovation, but innovation combined with good science. Here I must say that what is the difference between discovery, which is on this axis, which is invention, and innovation? You should remember, invention is using market knowledge, using money, grant money, resources from the nature, convert that to knowledge. That is basically the invention. Whereas innovation is exactly opposite. You have high quality knowledge. Those knowledge can now be used to harness it back to the nature. So essentially, you use market to generate knowledge, that is invention. And if you go from the knowledge to the market, back to the market, that is actually called the innovation. So in a way, they are complementary. They are two different arms, knowledge to market to knowledge, and knowledge back to market. And I think both are very, very important. That is, you gain knowledge, using the knowledge, you make the innovation. And that is the goal of the NEP. Whenever you talk of science, fundamental science, or any kind of science, you always talk of Nobel Prize. And if you look at the Nobel Prize by the Indians, the Indian origin, you can hardly talk about a few. So C.V. Raman, S. Chandrasekhar, Hargobind Khurana, Venki Ramakrishnan, only very few that you can think of. And where is the next one coming? We don't know. And that is one of the major problems in India, that very significantly important science is not happening. So science in India has to catch up. I think that's a very important part with the Western world. The ancient Indian science, of course, was very, very good. Unfortunately, it is not documented. Even chemistry in ancient India was very, very strong. In fact, lots of use of minerals, even in Vedic era. Harappa, Mohenjo-daro, of course. So many evidences are there, but much of it has been lost. Inventions like zero, number theory, in fact, very famous number 1729. Many of you know this number is a sum of two pairs of cubes, 10 cube plus 9 cube, 12 cube plus 1 cube. I mean, of course, number theory has a lot of origin in India. Ayurveda, of course, many of you know Ayurveda is an Indian origin, but geometry, algebra, what is interesting that even computer algorithms came in slightly after the Vedic era, and I have seen some of the algorithms in India. It is written in a very different language, which actually predated the algorithms, modern algorithms that exist today. So I think that a lot of things were there, but somehow we have to now, since we have lost many of it, we have to catch up. And that requires a learning process. And the learning process is very hard. For example, since I'm chemist, I'm again talking. In chemistry, when you learn, you really do not have an instinctive knowledge. Physics and biology, at least you know. Physics, you feel it. Cricket ball, something dropping down, so you can see the Newton's law. Biology also you can see. You can see electricity. But chemistry is very hard because in school level, when you grow up, you don't know what is chemistry. You have no instinctive knowledge. You don't see anything. I mean, except for the magic that there's a color change and so on. But chemistry is much more. So that chemistry is very difficult to teach. In fact, the classroom teaching is one of the way that is called the transfer of information from the teacher to the student or book to the student. But unfortunately, many times the transmission line has such a signal to noise ratio that what we want to convey gets lost. In fact, there is considerable evidence that both learners failing to make sense of teaching and of students developing alternative conceptions of the material presented to them. So that is very, very big problem. How do you teach? And learning has several different aspects. So one of them is an interpersonal versus intrapersonal activity. So students have to make sense of the new information in terms of existing cognitive structure. Teachers must therefore help learners gradually reconstruct for themselves the conceptual structure of a subject like chemistry. Is very hard. And this is why I think teaching chemistry is very hard because of the fact that we don't have an instinctive knowledge at the school level. The deep foundations must be firmly in place before any attempt is made to put together the higher concepts. That is very, very important. Many times we go to very higher concepts without the foundation. So I'm just saying that is something that we cannot do. So scaffolding is a very important metaphor that is used to describe the teacher's role in helping the learner build the edifice of a subject. So I call it as scaffolding. So you have to use the scaffolding. Chemistry itself is quite interdisciplinary. It's diverse. In fact, I dare say that many times I feel that the most physical chemists are working on a different paradigm than the organic chemists. The paradigm itself is different. Though today, lot of computation chemistry is integrating organic and physical chemistry. In fact, Professor Vidya Ussare, with whom I have a good collaboration at SP College, she is very, very eminent now to use physical chemistry for organic chemistry reactions. So I think it's very possible that many organic chemists are actually grafting physical chemistry. But the concept of physical chemistry has always been quite different and more driven by the physics paradigm than the chemistry paradigm or biology paradigm. Of course, for many subjects, you can say this, but somehow I feel that physics has a more commonality of approach. Biology, of course, is very broad, but biology has live experiences, either with plants, with animals, that's botany and zoology. And then we believe there is a hierarchy of sciences, and that's a problem. So we believe that physics is built on mathematics, chemistry is built on physics, biology is built on chemistry, psychology is built on biology. Now that's the standard hierarchy which people have believed in. However, this hierarchy is not right. The maths is not only a tool which is used in physics, but can be used in biology today. A large part of biology, which does not have any application of chemistry. Psychology, it is not necessary that it is built on biology. It can be done completely independently. In fact, part of the psychology is today called social sciences. So it has nothing to do with the biology per se. So the hierarchy of science is actually breaking down. So for example, today, the modern chemistry, chemistry started in alchemy age, just like a magic, how to convert, the cheaper metals to the heavier metals and gold and so on. So the alchemy age was very exciting. A lot of things happened, but people didn't understand why it is happening. Today, the modern chemistry, in fact, Lavoisier, I call it Lavoisier, the father of modern chemistry, is heavily dependent on electrostatics, quantum theory. In fact, it's very hard to envisage a modern chemistry without quantum theories. So the chemistry student is expected to appreciate the physical basis for the ideas. But it's not very easy. Not very easy because you have to compartmentalize the chemistry from the physics. I will not worry about it. But I want to tell in terms of research itself, chemistry is changing. Chemistry is moving from structure driven to function driven. I think that is very, very important. Old days, chemistry used to synthesize molecules. Chemists also synthesize materials. And then they use spectroscopic tools like NMR, mass. Okay? For materials, you can use microscopy of different kinds to get the structure. And then, once they get the structure, they look for an application. But I think chemistry will slowly change. We have to first focus on the applications. What is the function I want to do? And then look at what structure will give a property that will do this function. So that's very important. And that is what I say, structure driven to function driven. But to do that, you have to break the traditional barriers of discipline-based chemistry. Chemistry will also be driven by emerging areas of research. So there are lots of emerging areas of research. And chemistry, of course, appreciation of chemistry will come if you read some history. So for example, as I said, oxygen started the chemistry. Lavoisier, the father of chemistry. And you can look at the modern chemistry started with atomic theory, molecules, Avogadro law, urea synthesis. Of course, a great part of chemistry in urea synthesis. It really started the synthetic chemistry in the world. Then, of course, the structure of benzene is very important. That Kekulé, came up with the structure of benzene, and this actually started with all kinds of ring separate structures. Periodic table, of course, no chemistry can be done without periodic table. All of you know the periodic table is the workhorse of the chemistry. Electrolysis by Davy, discovery of electron. Electrons were discovered 100 years after batteries. You cannot imagine. Battery, the conductivity people knew, but electrons came much later. Radioactivity, plastics, polymer, and of course the Bohr's theory, which started the first hydrogen atom, chemical bond by G. and Lewis. I must say this, they are not quantum chemistry, but eventually the quantum theories came up. And the modern chemistry was enriched with many of these in over a period of time. 250 years, let's say 250 years, the modern chemistry has been going on. But today, when we do chemistry, we have to understand the problems. And major problems are actually on energy, on the renewable energy from sustainable resources. So we will just tell what are the sustainable resources. Can we make buildings which are energy efficient? In fact, I see a lot of buildings in many universities abroad which are energy efficient. You don't have to put the lights. The light automatically comes, the sunlight comes, and the windows move as the sun moves so that the sunlight comes. But there are many other ways of getting light. So energy efficient building is very, very important. In fact, one example I can give you for energy efficient building is that if you have a crack in the building, today somebody has to come and look at the crack and then fix it. It is quite possible that this crack can be fixed automatically. So this is called the sensing, that there will be a sensor which will immediately understand that there is a crack in the building. Either the engineer, a report can be sent to the engineer, or even if the engineer does not come, even better is that it can actually correct itself. Of course, there will be some resources which will actually flow there. Those resources have to be again refilled after a period of time. But for the time being, a smart building will be able to do that. I think that's very important to realize that we are nowhere in constructing energy efficient buildings. Of course, a lot of people are talking of green processes, green chemistry, which are environmental processes. And of course, more I talk about healthcare, whatever I talk of healthcare is not enough. We already know what COVID has thrown into us. So it's very, very important to work on healthcare, but affordable healthcare. When I talked of sustainable forms of resources, these are some of them. Solar energy, as I told, and sunlight is plenty in India. So you can convert to heat and electricity, wind energy, fuel cell, and that is the hydrogen powered economy. In fact, a lot of people are working, and I am also working on hydrogen storage. How do you convert hydrogen to fuel? And hydrogen, of course, is a very big source and very clean source, because when I burn hydrogen, a lot of energy is produced and you get water. So that's a very clean energy. Bio waste to alcohols and chemicals. And there's a lot of work that is going on. In fact, we have a lot of projects here. The SP College is also part of it, where you're talking of carbon dioxide, into chemicals, value-added chemicals, conversion of carbon dioxide to value-added chemicals. So many of these will happen by what I call the smart materials, which are man-made materials and structure which are intelligent. So a structure that could give engineer a report on the problem, as I told you, or having the ability to counteract unwanted condition. So the smart materials are man-made materials which are intelligent. Today, of course, the materials which are made in nature are intelligent. And man-made materials are often dumb, like the table, like the chair. But can you make materials which are intelligent? Those are called smart materials. For example, fuel cell, some of the applications in fuel cell, artificial photosynthesis. It's a very big stage today in artificial photosynthesis. So many areas are emerging. In fact, energy materials is a very important area. Pharmaceutical is, of course, going to become more and more important. And today, a lot of interest in pharmaceuticals, search for drugs and vaccine, not just vaccine, but also drug. The vaccine takes time, as many of you know, but you can have a search for repurposed drugs that might come very quickly, new and repurposed drugs. And I think a lot of work is going on. You will hear a lot more in the reference to COVID, I'm sure, in near future. Renewable source of hydrogen, I already talked of. CO2 activation, and that's what I said, to value-added chemicals. In fact, we are having a project, SP College is also a part of it through Professor Avsare. Synthetic biology, I must say, synthetic biology is going to become a very important area of research, where learning from biology we can do chemistry. And by the very name, it's an interdisciplinary area. And I think a lot of people will be working on synthetic biology. As the new normal comes after the COVID, we have to look for the environment. How do you protect the environment? How do you restart industries without polluting the environment? What are the innovative ways to carry out research in this new normal? I hope all of you know what I mean by new normal. That is, after the COVID goes off, what is the normal thing will come? Of course, the COVID-19 itself has thrown a lot of challenge to environment, climate. We have to bring in technological innovation. More of digitalization will come. The very fact that this talk I'm giving, sitting in Kolkata to a science association Pune, just shows that what is possible today. Education has already gone online, and that's very important. Technology-enabled tools are going to become more and more important. Laboratories is the immediate future. One has to see how to do the laboratories. As I'm talking about it, in terms of research, very similar integration is taking place through computational science. And I must talk a little bit about computational science before I close this talk, because this is one of the multidisciplinary talk. That's the way forward today. Many experimentalists are using theory, computers, algorithm to solve complex equations from theory, predict in computer structure and properties of molecules, predict reaction between the molecules, if the reaction takes place and how fast it takes place, dynamics of evolution, model new materials, biological activities. Many of these now can be actually done by computation. Without even doing experiment, one can actually try to predict. And I think in the COVID era, many people have taken to computation. In fact, the very fact that how COVID is spreading, how the virus is spreading, is also done by computer simulation. In fact, all of you have seen many results. Many of them have not lived up to the expectations. Many are trying. But I think there are many, many efforts to the computation. Computational chemistry is going to become extremely important. I may end by saying what are the areas of research that I'm doing in my group. We started from NCL to IIT Bombay to IISER Kolkata. Many developments of theory, a lot of computational work. In fact, lots of computational work and materials today. But I started mainly of developing theory, and slowly we moved. We looked at reactivity of molecules, which are very, very important. And slowly I moved to the application area. For example, catalysis, aromatic, anti-aromatic compounds, hydrogen storage I already talked about. In fact, in catalysis, we are now, in collaboration with Professor Osar again, I'm doing computational catalysis. And I'm not going to talk about all those work, but a lot of interesting work that we have been able to do. And today, by computation, it is possible to actually go from A to Z. So we have what I call horses for the courses. So you have like if you do protein, you have one kind of theory, which are known as the force field, the molecular dynamics. If you have membranes, you do coarse graining simulation. If you have atoms and molecules, you do quantum. So depending on the length of the system, you employ theories. And that is becoming a very important thing to realize. These are just some of the very interesting things that you can do a lot of travel. I go for a lot of conferences. Today I fondly recollect this because the travels are almost zero now due to the COVID. So I fondly recollect, and I just put together some from my website, some of the travels. I hope all of you can recognize me. This is me, this is me, this is me, and so on. So I think at different places in the world, it has been an exciting journey, I must say, doing computational chemistry, doing computational science, teaching interdisciplinary research and education in institutions like IITs and ICERs for a long time, because I have been teaching in ICER from 2006. It has been a great journey, and I believe the time has come where we must integrate research with education. And that is my message to all the young students. The message to go forward, way forward, is to integrate research with education. I'm very happy that the government has come up with national education policy. I spoke a lot about it. The national education policy, which actually lays very similar path. So I hope this will be used by not only students, but by faculty. The degrees, there are so many different exit degrees now. That is depending on what you are, you can be employed. And it's not that if you can't pass one particular thing, you just remain blank. I think that is what this NEP is also trying to do. So I think very exciting times are coming up in this country as well as in the world. And I hope with that I will end. I didn't want to talk much about my research. I'm very active in research. As Dr. Musle said, 250 or 260. I think that data is a little bit outdated. I've already crossed 285 publications. So I keep publishing. I already had more than 40 PhD students and so on. So just another 2 PhD students are going to submit thesis next week. So I think it has been a very, very interesting times. When you grow old, you try to reflect on, what are the times that you have crossed. And I think it has been very good. And I've enjoyed partly research and teaching in an integrative manner. And the fact that I was at IIT Kanpur in 1972, being taught by great chemists, I must say, the greatest of the chemists in the country have taught me. C.N.R. Rao, Professor C.N.R. Rao, Bharat Ratna, he was my teacher. Professor Govardhan Mehta was my teacher. And I really feel some of them have enriched me so much. In fact, IIT Kanpur was a who's who of chemistry at those days, in the 70s. And I think that has also helped me to grow. And I'm pretty sure for the students, when you become student, you don't know what will happen. But you keep faith, keep working, and keep your mind uncompartmentalized. And remember, you can't be a good educator if you are not a good researcher. Do not disconnect education with research, because your education will also go bad. I think with that, these are some of the acknowledgement on the education part of the sources. With that, I will close my talk, and thank you very much for listening. I think I'm just about a little bit less than 1 hour I have closed here. Thank you very much.
Thank you, sir. Very enthusiastic and informative talk on the topic of integrative science a way forward, since as you told us that now in coming years the national education policy 2020 play a very important and significant role on the field of education. So now, with your prior permission, we have few questions. Can I move ahead, sir?
Yes, yes, yes. Should I come out of this
Yeah, yes,
or
sir.
to
No
stop
problem.
sharing? Yeah,
Yeah, you can stop the sharing.
yeah. Okay. Yes, please tell.
Uh, so, sir, we have a question that related with the as you have discussed the multidisciplinary education. So, can you comment on the holistic education, since that is again means we have a divergence between the art, science, and commerce. So, is it possible to come up with
Yeah.
some art subject and we can support the
Yes.
scientific? Uh,
So I think, yeah, I think there are a lot of thoughts which are going on how to give holistic education. So of course the humanities, the way it is taught in the humanities departments is not required for science. So you need the humanities that gives you an idea of human the human qualities of a science. That is very, very important. And remember, the science is for society. So what you require when you learn humanities or social sciences is to understand why are you doing science. I think many of us, because we are completely divided or detached from the social sciences, has the problem is that we have forgotten why we are doing science. The fact that the science should be done for the society is something that is forgotten, and that is essentially a problem, that we have become silos. We don't know why you're doing science. So the social science and the humanities will give that perspective. So the question is, how do you teach? In fact, I will tell you, in our IIT Kanpur model 50 years back, we used to have every semester one course on humanities. And much of it was elective. So somebody would take logic as a course, somebody will take economics as a course, somebody will take a philosophy as a course, but there used to be at least one course of humanities. So in 5 years, in 10 semesters, we probably did 7 or 8 at least humanities courses, apart from English. English was also taught as a part of the humanities course. I think it's important to go back. I would also say the history of social sciences and the history of sciences should also be a very important part of the course to make it holistic.
yeah,
And as I said, to make things holistic, it is more important that the subjects should not be taught in silos. I'm coming up with a very specific suggestion. Thermodynamics is a very, very interdisciplinary subject. Physics people teach thermodynamics. Engineering people teach thermodynamics. Chemistry people teach thermodynamics. Is the thermodynamics different? The answer is of course no. How do you, but the thermodynamics as used in chemistry, as used in physics, as used in engineering has a custom difference. You have to customize. How do you teach that in an integrated manner for all of them? The basic concept is very important. So then you don't need to repeat many courses. So I think there are many, many modules which will come up in one theme which will integrate. So the holistic science is, of course, a very important concept, but many of us still do not know how to actually achieve that. It's very easy to say, okay, you do holistic science, but it's not at all easy to achieve that. I think the holistic science has to be understood. Somebody with a very great breadth of knowledge can connect mathematics to biology. Which part of biology requires data science? Today we all know artificial intelligence, machine learning, everybody talks about that. But particularly in biology. But I think it's very important to achieve that aspect of holistic science. And we must start. Unfortunately, the problem in many universities is the syllabus itself has not been changed over the years.
yeah,
And I think the integration of different subjects, integration of humanities and social sciences must come in the syllabus itself. I would suggest logic. Logic is a very important course. Many science people, students, they do not know logic. So one of the first things we learn, if there is rain, there is crop. It does not mean that if there is no rain, there is no crop. But what it means is that if there is no crop, there is no rain.
Yeah.
So if A implies B, negation of B implies negation of A, not the negation of A implying negation of B. I think I have seen young students very difficult for them to understand this because the logic is not taught. So logic and economics, social sciences, these three subjects must be taught, and the history of science.
Yeah, yeah, sir. Thank you. Thanks a lot for the good answer, sir. Now, the next question is that we know that a lot of efforts were taken by the committee and the chairman to propose the national education policy in front of us.
Right.
But
Yes.
uh, some points they have highlighted, like that higher education, none of the students will be deprived from the higher education due to the financial inability, so or something like that. Every required students will get the hostel facility or boarding facility.
Yes.
So
Yes.
as
Yes.
India is
Yes.
a huge country, yes, too much population is there with us. So is it possible to in actual we can provide the facility to each and every individuals?
Of course, I mean, but this will take time. I'm pretty sure there are lines in the national education policy, and many of them have to be implemented. Many of them are implementational part. This implementation has to be, of course, done by the government, has to be done by the other stakeholders. In fact, I believe industry should also come up, NGOs should come up, private institutions should come up. And in fact, you are talking of the holistic university, one of the universities where I'm associated now as a visiting professor, Ashoka. Many of you have heard Ashoka University. It actually tries to do exactly that. That the students who come up, they don't know if they will learn history or chemistry or physics. In the first semester, they take everything and then they decide, depending on their interest. So I think it is possible. Universities like Ashoka must grow. There are many such universities which must come up, and the private institutions should actually engage themselves in many of the implementations of this holistic science. And many of these that we are talking of, hostels, money, getting everybody to have education, will definitely require funding. And I'm sure though those that is where the government and the NGOs and the private organizations, industries must play a very important role. So obviously there are implementational aspects, otherwise NEP will not be successful. But
Yeah,
the intent of the NEP is good. I
correct.
myself talked to Dr. Kasturi Rangan, who has been the chairman. In fact, I was in a panel. The intent has been very good, I must say that.
Right, sir. So we have another question that means, as you have highlighted the growth of science at ancient times. So what will be the situation in the coming decades? Since actually, as you also have highlighted, we are lagging in the Nobel Prize achievements and all.
Yeah.
So what you are thinking about the future of science in India in the coming decades?
Yeah, that is this is a very difficult problem to say. I mean, many people ask, how do you get Nobel Prize? I mean, I normally say that if I knew, I will first get Nobel Prize. So, I mean, nobody knows how to get Nobel Prize, right? I mean, nobody can
Right.
tell. And I told you how the research takes place. Like Archimedes made a discovery. Archimedes didn't know that he would discover this, but only because the king hero told that my goldsmith is cheating, he had to find out the density of gold, the density of a material, and then there has to match the density of gold. So then Archimedes started thinking, how do you get the volume of an irregular substance? And then he went to the bathtub, and you know the story of Archimedes. But why did he do that? Because King Hero challenged him, and those days kings were ruthless. Had Archimedes not been able to do that, maybe he would have been killed. So it came through a necessity. Isaac Newton, I mean, maybe it's a story that he saw the apple falling, but I always wondered the apples were falling all the time downwards. How come nobody saw it? Or did anybody see and not worry about it? It required. So how did Isaac Newton come up with the laws of motion? I mean, it's amazing story. How did Isaac Newton did optics? How did Isaac Newton, one man, did the calculus, integral and differential calculus? So it requires great minds. The great minds have to be nurtured. I think that is very important. And the system has to be developed such that the great mind do not lose interest. I think that is very important. So many of our research labs and educational institutions, there is a demotivating factor. And that has to go. The people who are good minds, they should prosper. And one has to remain alert. And that is where I'm saying the discipline itself is not important. A chemist can get a Nobel Prize in physics or vice versa. And there are so many examples today. So I think that is a very important part that we have to remember, that we should not compartmentalize ourselves and think and remain alert to all the five senses. It's very important. Look around what is happening and think out of the box. Many
Yeah.
of our, I tell you, many of our universities, the problem is that routine. You give exam, you mug up, and you get marks. And that is defeating the purpose. Because then the students will never go out of the textbooks. If you are only following the textbook, you're obviously not going to come up with original idea. Because those ideas are already there in the textbook. So I think some of these mindsets have to change.
Yes, sir. Thank you very much, actually. And I think, as you have highlighted, out of box thinking is important, and NEB proposed the view of examination
Yes.
conduct, that they are going to change. And now the examinations will be not based on the memorization, but the overall thoughts and
Right.
logical view they will consider about the
Yes.
students. So that is a good thing for the student sides as well as for the science culture. Now we have some interesting questions. So that teacher truly shape the future of nation, or suppose here in India,
Yeah.
they will shape through the
Right.
education. So what kind of advice you will give to them, since as they are the backbone of educational system?
Yeah, I think the teachers have very big role, of course. First of all, you must know how much to teach and how much you need not teach. So in the classroom, you must allow the students to think rather than see most of our classrooms are one-sided. It's a monologue. The teacher gives a lot of information without understanding if the students are able to accept it. So I think there has to be a much more of a one-to-many interactions. And I think the teachers have to break the traditional discipline based education, and that is a very important. So I think the teachers training is an extremely important part, and that has to be done by very good people. So one has to have a resource of good teachers who can actually look at multidisciplinary research. They must train the teachers in different places. Then the teachers must go to the students. How do you teach is an art. I tell you, it's an art more than any science. Nobody will tell you how to teach. You have to actually look at the students, look at the quality of the students, and then decide your teaching strategy. The same size does not fit all. You have to remember that. The same strategy of teaching will not be good for very big students and very mediocre students. So we have to see what kind of strategy will work. So of course, teachers have a very big role in the new education policy, and they must emphasize the role of innovation in the classroom, innovation and of course multidisciplinary research.
Thank you, sir. Actually, very wonderful talk, and we are thinking that NEP brings a very bright future to the students due to the more flexibility to the students itself inbuilt in that particular policy. And now there is a lot of choice to the students, as you have pointed out, at the graduate, postgraduate, as well as uh, research levels.
Yes.
So I have one questions related with the research level, that means at the at PhD positions, actually NEP expect the teaching kind of thing from the students. So that means the
Yeah.
compulsory they have to involve the PhD students in the teaching field. So
Yes.
since if the teacher is not interested, the researcher is not interested in the teaching curricula, then is that will affect in diverse way for the research.
Yes. So I think yes, that is true. But at the same time, I think that these researchers who are doing PhD students, they must be able to teach. So that will actually enrich their research. That will also tell them what kind of research should be done to make effective teaching. So I think in India the problem has been that the teaching and research have always been separated. So I have been teaching for a long time and doing research. I don't find there is any dichotomy that if you are a good researcher, and that's also another bad concept. If you are good researchers, you need not be a good teacher, or a
Right.
good teacher is not necessarily a good researcher. I think that's a wrong views. So a good researcher must be able to teach well if the
Okay.
fundamentals are strong. So I believe that even the PhD students, if they go and teach, there is nothing wrong.
Yes, sir. So thank you, sir. Thanks a lot. Now we have our active colleague Ajinkya Thorat from Department of
Yeah.
Chemistry. So
I just want to
yes,
tell something. I find some questions in the chat box which are
uh,
not answered. Like somebody has asked scope in astrophysics in
yes,
India,
sir. Scope in astrophysics in India. That is what the
and
question.
somebody has asked what are the where India stand in research in the next couple of years.
Yeah, that I have
Well, I
asked
don't.
you in coming
Yeah, I
decades.
don't think
And
in
this
yeah in
question is
next
related
couple of
with
years.
astrophysics.
Yeah. So I just want to say next couple of years is too short a time for things to change.
Right,
So the change will certainly take a decade, I believe.
right.
Uh, and as far as astrophysics is concerned, I know that astrophysics is a very popular subject, particularly in Pune, because of course, the Ayuka and so on. And there are a lot of students who take interest in astrophysics. In fact, a lot of people come to physics for astrophysics. I know that. So astrophysics in India is, of course, quite strong, and there would be a lot of scope for astrophysical research. In fact, there are Astrophysical Society of India. There are a lot of things they do, and astrophysics, because of its interest, of a very wider interest, will always be of excitement. However, I don't believe that too many students should go to astrophysics. I mean, that's my own feeling. I think the number can be limited, but the subject itself is of interest, and I'm sure those who want to pursue, there will be the scopes are quite huge. And we have very good astrophysicists in this country, I must tell you that. I mean, of course, very close to your home, Ayuka is there.
Yeah, yeah.
Ayuka, GMRT,
Actually,
and so on. Yeah.
we have organized number of lectures to the students. Those are
Yes.
interested in the astrophysics, and we also have Astro Club at our college that is started
Right,
by
right.
students themselves, and we are very much interactive in that point of view. So thank you, sir. Now I would like to
Welcome.
request Ajinkya Turat, sir. Please give the vote of thanks for the today's talk.
Yes, yes. Thank you, sir. Thank you, Kakade, sir. It's an honor to thank our eminent speaker, Dr. Saurabh Pal, on the occasion of Science Association Lecture Series. On behalf of my college, a very hearty gratitude to Dr. Pal for sharing his graceful words with us. I'm sure that all the attendees are benefited by the knowledge and ideas shared by you. Finally, I would like to take this opportunity to thank all the participants for attending the session and to our Science Association team for uh, working in such a good way. And thank you again and have a great evening, everyone. Kakade sir, I would like you to conclude.
Yeah,
Thank
yeah,
you.
sir. Thank you. Thanks a lot.
Yeah.
So now, officially, I would like to conclude that today's session is over, and I would like to request you that please join for the tomorrow's session at 6:30 p.m. on same link. Thanks a lot.
Thank
Thank you.
you. Thank you very much
Good
for
night,
your
all.
attention. Yeah.
Yes.
Thank you.
Yes,
Bye.
thank you. Thank you. Bye-bye.
Thank you. Jayesh, can you end the broadcast?